All right. Now, before we start taking notes, if you can't read something, just ask me. My handwriting is not stellar. I do try to write neat, but sometimes by the end of the day, after I've written this stuff multiple times, it's just not as good as it could be. So, we're going to start with measurement. Because you're in an honors class, some of the stuff I will teach you is extra and beyond the curriculum. Part of what we're doing this week is the extra and beyond the curriculum because you're in an honors class. It is not going to be on the state test, but some of you will eventually take AP Biology or AP Environmental Science, and you're going to need to know it should you take those courses. So I teach this for those teachers. So first of all, what is measurement? It is a unit of defined size. Now, most of you are familiar with US and metric units. All right. In the US, we use English units. Give me a couple English units that we use here in the US. Just anything. What? Liters we're going to talk about in a minute. No. Inches will work. Okay. Nope. And one more. How you buy your milk? Yard will work. That's not how we buy our milk. Yeah, gallon will work. All right, all of those are English units. Now, scientists do not use English units for anything. Okay, they use SI or metrics. So we need to talk about SI units and metric units today. All right, everybody caught up? You giving everybody time? All right, so what are these SI units that I'm talking about? Because we're going to talk about some SI units and we're going to talk about some common units because some of the SI units are so big we won't use them or we just don't use them. We're going to talk about length. We're going to talk about mass. We're going to talk about time. We're going to talk about temperature. And we're going to finish with the amount of substance. So, what do you suppose the SI unit is for length? What?
Meters.
Meters is correct. All right, so what is a derivative of meter that we might use if we need something smaller or something larger?
Large.
Give me something larger than meters. What? Don't go English. Stick with a meter. It would be bigger than a meter, but stick with the meter. Yeah. All right, so kilometer. All right, now go smaller than the meter. Sure. All right. Now, the SI unit for mass. This one usually throws people off. What? We're going to do volume in a minute. That's going to be over here in this column. How are we going to measure mass? What unit are we going to stick on the end of it?
Gram.
All right, gram is going to go over here. Gram is actually going to be a common unit. That's why I said this one throws people off, because it's backwards from what most people think. So what would be the SI unit? There you go. So the common unit here is gram, and the SI unit is kilogram. All right, what's times SI unit? Any guesses? Really? Y'all can't come up with a time unit that would work here?
Seconds.
Yes. Now, the common unit should be a breeze. Minutes. Give me one more. Sure. All right. Temperature. Degree what? Celsius is common. I'll put Fahrenheit up here. Fahrenheit's English, but it's used so much, I'll put it there. All right, so what's going to be the SI unit? Anybody know this one? Very good. Not many people know that one, but some people do. All right, the amount of substance. I only had one person who knew this in the first period. This one's out there. You'd have to have somebody who taught you this one. Anybody know it? This one's the mole. And we will not do a common unit for this one at all. Okay? But we will spend a lot of time talking about the amount of substance in moles this semester, more than you ever wanted to know by January. Now, do we all know how to measure the first four up there? How do we find a length? How do we find a mass? How do we find a mass? What's one been called? Y'all are pointing to it. What's its name?
The scale.
Okay, what's its formal name, other than just calling it a scale?
Triple beam balance.
You can read. It's a triple beam balance. How do we find time?
A clock.
Okay. Work, a clock or a stopwatch, and a temperature. Yeah. All right. Any of y'all remember metrics? All right. How did I know to do that? Other than I'm the infamous Miss Wall, and I just remember all that stuff because I've done it a long time. I know y'all know.
Oh, Ken Henry died by George.
There you go. All right, somebody back in one of your school years taught y'all King Henry died by drinking chocolate milk. Okay, that way you could keep the order of the units right. Now, DECA can also be spelled DEKA. Means the same thing. There's absolutely nothing wrong with either spelling. Now, do you remember the abbreviations? How do we abbreviate kilo? All right, now by the end of the day, we're all tired. I get that, but y'all got to talk to me. How do we abbreviate kilo? Like if we wanted to write it in an abbreviation form, like 2 letters. All right, just K. Because we'd have a prefix K and then like gram would be behind it. We'd write K with a G. All right, how would we abbreviate hecto? With that lone voice out there. All right, deca and deci are the 2 that people get confused. So how do we do that one?
DECO.
DA. All right, deci,
DI.
just D. Centi and milli, just M. Now, what goes on the baseline? Anybody remember what goes on the baseline? Something like gram, liter, meter. So, if I write mg, what does that mean? Passion, what does that mean? Remember, Miss Wall's old. I have all my senses. The only thing that dims with age is hearing. So pretend you're talking loud. Very good. I could hear that. All right. So if I say DAL, what is that, Agilin? Very good. All right. And what if I just write M and A? I gave you a tricky one. If it's just an M, is it a prefix or is it a base unit? What do you think? I'll get you some help. Brandon. What do you think, Kayla? It's a base unit. So what would you say it is? That's exactly right. All right, because this only has 1 letter, it's a base unit. So it's meter. In order to be a milli, how many letters would it have to have? Have to have 2 letters. So I would have had to say M, for example, for it to be milli, and then meter. Or mg for it to be milligram. So if I only have 1 M, it's just a plain meter. Does that make sense? Okay, everybody with me? Last thing to review. What happens? Where's bigger and where's smaller? What happens as we go top to bottom or bottom to top? Who's the biggest? Okay, so if the top's the biggest, as I go down, what happens? I get smaller. Everybody with us? Anything I've done on this particular page right there, something that you don't recognize, because this whole page right there should just be review from another math or science class. Everybody with me? Because now we're going to use it for stuff we're going to use in this class this semester. Everybody got what they need? Okay. All right. So the process we're going to use to convert this entire semester is called the factor label method. Okay? And this is the only day that I'm going to write this down, and we're going to use it the entire semester. What you got for me, my dear?
And you have one senior?
I have no idea. Do I have one senior? Isaac? Isaac must be it. Yes. Thursday is picture day. Hey, see if y'all don't know that. Let me give this to you now, or I will forget. Only 2 of those. All right, with the factor label method, we will be using all semester long. Every conversion that we will make from now until January, I will do with this particular method. So today is the only day I'm going to write these steps down. We will never write them again. We will just use them. Step 1, draw a chart. Step 2, put the given data on the top line. Number 3, put the unit you do not want on the bottom. Number 4, put the unit you do want on top. Number 5, put a 1 next to the biggest unit. And number 6, count spaces for the remaining spot. And I'll let you catch up. Yes. Can you what? Sure, that's fine. We can just set it inside that door, sort of back there, so it'll be behind the door so everybody won't mess with it. All right, has everybody had a chance to catch up? Okay, tell me when you got it, Cameron. Okay. All right, is everybody there? So, if we take a problem such as 458 hectometers, and we're going to change it to decimeters. Now, some of you, probably in elementary school, were ace wizards at moving decimal places. That's all sucked at it, okay? Wasn't very good at it. Could never move, remember if it was left, right, up, down, sideways, just couldn't get it. Some people in chemistry class, when I took it, could remember if we multiplied or divided, when we were converting. Again, hated it. Sucked that. Couldn't remember what. So this is the way that I could remember how to do this. So I didn't have to remember if I moved left, right, multiplied, or divided. And so that's why I like this. I also don't have to remember if they're decimals or if they're whole numbers. Everything's a positive number, and all I have to do is plug it in, and it tells me in the chart whether I multiply or divide. So, first of all, what is this chart I speak of? All right, the chart is just a T-chart. Now, it's shorthand for math class. This line means divide, just like it means in math class. This line means multiply. It is short for drawing parentheses. Divide, parentheses. Miss Wall's lazy. I don't want to draw those parentheses. So this straight down line is shorthand for drawing those parentheses. So anything that's on this side multiplies with that side. Okay? You with me? All right. So step 2. My given data goes on the top line. What's my given data? What I give you in the question. 458 hectometers. Now, for right now, if I had something under it, like liters, that would go down here. But do I have a hyphenated or a unit that's in the denominator? No. So for right now, I don't have anything that goes in that spot. If we move along fast enough, I might teach you that, but right now it's not important. So, step 3. What unit do I not want anymore? What am I trying to get rid of? So hectometers has to go on the bottom. The reason it goes on the bottom is so that it does what? I heard it. I thought it did. Cancels out. Number 4, the unit we do want goes where? On top. So what unit do I want? So we put it on the top. All right. The unit that's bigger, guess what? So our King Henry died by drinking chocolate milk. Who's bigger, hecto or deci? So we put a 1 next to hecto. Step 6, count the spaces to figure out the remaining number. So whatever we have left is going here on the top. So we have hecto to deci. We're counting spaces. So hecto is here. Hecto to deci is 1 space. Deci to the baseline is a 2nd space. The baseline to deci is a 3rd space. So how many spaces did I go? 3. We put 3 zeros because those are the 3 spaces, and metrics is base 10. So 3 spaces, and then I put a 1 in front of it. 458 times what? Times 1,000 divided by 1. I don't have to figure out if I multiply or divide. All I have to do is look at my chart. So 458 times 1,000. Like that. Questions? All right, can we try another one? All right, so let's say that this time we have 12.5 millimeters. Let's go milliliters. And I'm going to deciliters. All right, what do I do first? Okay. What goes on top? 12.5. Okay. What do I do next? Milliliters to the bottom because I want it to cancel out. What I don't want always goes on the bottom. Okay, what do I do next? Deciliter on top because I want it to be what I'm looking for. All right, what do I decide then? Who gets the 1? Whoever is biggest gets the 1. So King Henry died by drinking chocolate milk. So we've got Deca and we've got Millie. So who's bigger, the Deca or the Millie? So what am I putting beside the Deca? All right, so if we flip back to this one, here the one was on the bottom. Here the one's on the top. It doesn't matter whether the one's on the top or the bottom. The 1 always goes next to the what? Biggest unit, wherever that happens to be. All right, so now I need to do what? Count the spaces. And I'm not just going 1, 2, 3, 4. I'm counting Deca to the baseline to Deci, Deci to Centi, Centi to Millie. So how many spaces did we move? 4. So that means I do what? I don't just write 4, I do what? 4 zeros. And what goes in front of it? A 1, because remember, these are all base 10, so it'll always be like 10, 100, 1,000, 10,000. All right, so how do I calculate this one? $12.5. That's right. You can say times 1 if you want to, but it's 12.5 divided by 10,000. Everybody got it? Now, has everybody noticed on both of my answers, what did I make sure I wrote on the end of my answer? The unit. If you don't have a unit on your answer, you lose points. So make sure you have a unit on your answer. It has to be there. All right, can we try another one? Okay, let's do one more, and then I'm going to let y'all try. Let's just do that. All right, so if we do this, what do I do first? Alexis.
Yeah, you got the chart.
Okay, give me the second step too.
75.2.
All right, Isaac, what do I do next?
See which one to put it.
Not yet. We need to fill in some other parts first. If KG's on the top, what should I do next to my chart? Where should it go? If KG's here, where should I put it? On the bottom. And then where should I put, what should I put here?
H.
All right, what should I do next? Isabel.
Find out which one's the big one.
Now we want to find out which one's bigger. So who's bigger? You still think HG?
KG.
K's bigger. All right. You surviving over there? Is he here? All right. How many spaces between K and H? Okay. So we're going to put 1, 0, and 1. All right. So how do I calculate that? Allie. I know I said that wrong. Say it for me again. Eiley. We what? How we calculate the final answer? Yes. Any questions? All right, you guys think you can try a couple? So I can roam around and see who's doing it okay and who needs my help? Okay. All right, let's go with that. Grab a pencil and roam around here a couple moments to see who needs help. I'm killing you. I'm not trying to afford bail. We might need a collection.
This one?
Yeah.
If it's just Graham,
Mm-hmm. It's where?
it should be at the top of
It's on the baseline.
the base. Oh, okay.
Mhm. So far, so good. Keep going. What you got? That is grams. So who's bigger, gram or millimeter? Gram will be on baseline because there's no prefix before that. That'll be right there. Yeah, put your chart back. You have to draw a line. There's absolutely nothing wrong with it. So that just means that this is bigger. So put your one there. How many spaces between here and here? What you got? Okay. So, yeah, grams, milligrams is bigger. All right. There. How many spaces you got? Here, here. That's the one. I just couldn't see it. Look at the way you punched in on your three, sharp, right, punched in it. Good. Anybody else have a question? Lee, you wanna go for the first one on the board? You wanna go for the first one on the board? I got two still working. Pen's beside my computer. Keep going on. You're almost there.
Do I just write it beside?
That, or you can do it on the next board, just hit the blue arrow. You seem a little short, so, just hit the blue arrow, and then you have the whole screen to work with.
Okay,
You can put it anywhere you want to in the middle.
so it's 125 grams to grams. So you make your chart. Multiplication, division. You put 125 grams here. You want to cancel grams out. You put your milligrams here. Grams is bigger than milligrams, so the 1 goes here. And the spaces between grams and milligrams is 3. And you add each 1, then 125 times 1,000 is 125,000.
Any questions?
And I'm not sure.
I never said you were. How tall are you?
5.
5'2"? Okay. You've only got me, I've only got you about 3 inches, so it's all good. How about Andy? Who's Andy? That's Andy. All right, do number 2.
Did I just make a new page?
Sure. And whatever y'all do, don't break that pen, because it's the only one we have to take as a new one. If I said Zeph and Kiki broke the other one, would you know which 2 people I was talking about?
Yes.
Yeah, they broke the other one. And on this board, y'all can make a big hand or a little fist to erase to. All right, so that's 125.
Yes.
Okay. Any questions about that? All right, last one. Let me have Anna. Susanna. Okay, you're not done? How about John? You done?
Yep.
Okay, do the last. You're gonna make it teeny time.
How do I erase it?
Big hand. Just hit the little arrow to the right.
Okay. Okay.
Any questions? All right, let's talk derived units. All right, so derived units. There are 3 of them we're going to talk about. We're going to do 2 today. All right, we're going to start with area, and then we'll finish with volume. All right, what do y'all know about area? Tell me the formula. Okay, so everybody learned area is length times width in math class. So if you had a lovely little square, rectangular, anything, if we had 4 centimeters on this side and 2 centimeters on this side, and I asked y'all to calculate the area, what would y'all tell me the area is?
8 centimeters.
Needs a little more.
6.
What?
Wait.
It's going from bad to worse.
8
8 what?
centimeters. I mean, not centimeters.
Let me write it down, and maybe that will help y'all. What's the piece y'all are missing there? I thought I heard it from somebody. Okay. All right. 8 centimeters squared. All right. Because you said a centimeters times a centimeters, y'all know from math class that centimeters times a centimeter is a centimeter squared, right? Okay. So anything that has a square on it, all right, makes it an area. Now, my question is a centimeter square a common unit, or is it the SI unit? What you think out there? It's the common unit. So, what then is the SI unit for area? Well, suppose we go back, oops, too far, to here. What is the SI unit for length?
Meter.
Meter. All right. Now let's cruise back up here to page 11. And we know the SI unit for length is a meter. What's the SI unit for area? What's the SI unit for width? What's the SI unit for width? Just walk through. We're used to it all day long. I know. There's no avoiding it. You either have to interrupt me or Rector, unless you want to go all the way around through Thornhill's room because she has fourth period planning.
I could do that.
So, what's the SI unit for width? What's the SI unit for length? What's the SI unit for width? What did you say, Shana? Yes. So, what's the SI unit for area? All right, so the SI unit is meters squared. Okay? The SI unit for area is meters squared. We don't use meters squared because meters squared is gigantic. Picture a meter by a meter. It's huge. And because it is so huge, we don't use it. Okay? Now, we're more likely to use centimeters squared. Now, we don't calculate a great deal with area in chemistry class. Everybody got what they want? We're going to use volume. So, let's talk volume for a minute. Tell me the formula to calculate volume. Not of a triangle either. Okay. So volume is length times width times height. So let's just say for a moment that I draw an ugly cube. Okay. And I'm going to say that this is 2 centimeters by 3 centimeters by 4 centimeters. All right. And we're going to find its volume. What do we get? What do we get?
24 centimeters cubed.
Okay. So we get 24 centimeters cubed. All right. So because this has a cubed on it, this tells us this is volume. So anything that had a squared was a what? Area. Anything that has a cubed on it is a what? It's a volume. So again, just like we just did a second ago, a common unit is what? Centimeters cubed. So what does that make the SI unit for volume? Very good, Andy. All right, volume is length times width times height. So it's meter times meter times meter, which is meters cubed. So this meter cubed is the SI unit. Now, we don't use meters cubed because a meter cubed is like this tall by out here by out here. If I sent y'all to get a meter cubed of Pepsi for me to drink, most of y'all would need a hand truck. Some of y'all would need a forklift or a crane, okay? Because you wouldn't even be able to use a hand truck to tilt it back and push the wheels out to bring it to me, okay? It's just that heavy. So meters cubed is gigantic for us to measure volume. Now, I'd love a meter cubed of Pepsi. My doctor would not be impressed with me. So I have to taper it down into much smaller volumes. So centimeter cubed is more manageable for me. So can you give me another common unit we measure volumes in that you're used to seeing when you go to the grocery store, or maybe you go to the convenience store to buy a water or a Pepsi? What? Liter's good. All right, something smaller than a liter because you might not need a whole liter.
Ounces.
Ounces is English. One more. They'll probably be on there. Quarts is English.
Milliliter.
Milliliters. Okay, these are the three that we will use primarily this semester: centimeters cubed, liters, and milliliters. Okay, everybody got it? Now we're going to do some math with those, and then we'll probably be out of time. All right, so we're going to start with the easy conversions first. cubed units to cubed units. These work just like we just did. So suppose you have 458 meters cubed to decimeter cubed. Now, how does this look different from what y'all just practiced?
It's cubed.
It's cubed. That's the only thing that's different. When you look at these, they're both cubed. It's the only thing that's different. All of the steps are the same, except one tiny little addition we'll do at the end. So, what do we need to do first? Draw the chart. All right. What do I do next? Okay, 458 meters cubed goes first. All right, what do I do next? Okay, next. All right, dm cubed out here. All right, what do I put next? All right, which one's bigger? The meter or the decimeter? King Henry died by drinking chocolate milk. Now, this is often missed on a quiz or a test. People look up here and they go, oh, look at this. Millie, Deci. And they pick Deci every day of the week. This is wrong every day of the week. How many M's do we have right here? That is a meter because there's one M. It is sitting on the baseline. All right, it is right here. Deci has a prefix, so it is sitting right there. So who is bigger? The meter is bigger. So we're going to put a 1 next to the meter. How many spaces between the meter, which is here on this baseline, and the deci? 1. So we're only going 1 space and putting a 10 there. Now, here is the new piece. Okay? If both units are cubed, cube the numbers. Okay? If both units are cubed, cube the numbers. Now, we don't cube the starting number. That was given, oops. All right, genius. We don't cube the 458. That was starting data in the question. We leave that alone. We only cube the 2 numbers we put in. So we're cubing what numbers? The 10 and the 1, because those are the numbers we put in. All right, does everybody know how to raise something to a 3rd power? That's that up caret key on your calculator that's like above the divide sign. Okay? So 458 raised to the, whoops, nope, this wall's doing it wrong. 458 times 10, then raised to the 3rd. And when you do that, I get an answer of 4, 5, 8, comma, 3 zeros, and then dm cubed. Like that. Huh? It's a lot warmer here than the starting room. Our room's like an icebox. All right. Any questions? Everybody with me on that? All right. Now, the one that causes issues, because this is usually the one that people do okay with, is going from something that's cubed to non-cubed. So, suppose we have something like 45.8 centimeters cubed to liters. See how this one's cubed and this one's not cubed? That's where usually we get hung up. So, how are we going to do this one? This is where you have to know a relationship that I'm going to tell you right now. 1 centimeter cubed is equal to 1 milliliter. These two things are one and the same. Generic one? I know that worked. But that was old school, I was going to say. I did mine last night at 5:30. All right. Now, anybody had Miss Williams' class? Did y'all talk about cc's? Remember we're talking about cubic centimeters, cc's? Volumes? Yes or no? Okay. If she ever talked about 1 cc's or any kind of cc's, those are the same things as those. Okay. We don't ever write them that way. We always write cm cubed as opposed to cc's this way, but it's one and the same. Okay. It's the same thing as a milliliter. All right. So, how are we going to make this conversion? There's lots of ways that I can show you this. Over the years, though, I have found that if we try to put this in a conversion table, students generally mess it up. So, this is my recommendation. When you see centimeters cubed, you need to know centimeters cubed is the same as what? It's the same as a milliliter. That's the same thing as 45.8 milliliters, and you're changing milliliters into what? Liters. It's much easier if you will recognize that, because as soon as you try to change centimeters into liters, you're going to mess the conversion up and you're going to have it off by at least 1 decimal place. But if you can recognize this and this is the same, you're making the same conversion you've been doing all day, and you're going to do it right 9 times out of 10 or 10 out of 10. Okay? So you're going to say 45.8 milliliters. Who goes on the bottom? Milliliters. Who goes on top? Liters. Who's bigger? Liters. Spaces. 3 because it was from the baseline. And then you're going to divide and get 0.0458 liters. But you've got to be able to say this and this are the same. That's the connection you have to be able to draw to do this conversion successfully. If you can do that, you'll be fine. It's when people can't do that that we have a hard time with this conversion. Are we okay with that? We'll practice some? Yay or nay? I think we should. Okay. But until, we get a feel for each other, I won't know when y'all are going, yeah, I got it, Miss Wall. And then I grade a quiz and I'm like, yeah, they said they got it. They ain't got it. It'll take us a week or so for me to figure out when you got it, when you don't have it. All right. Let's say that I give you all right, let's do those 3. And then we'll see where we're at, because I can't figure out when the heck the bell is ringing today. Seems to be about 3 minutes early. So I think we'll get out at about 3:27, which gives me about 10 minutes. Best I can figure. They go down smaller, so you figure. Yep, how many spaces is that? Yep. Now, you see how both of these are cubed? Cubed. Both numbers, since they're both cubed. You see how does that? Okay. Yeah, it is one number, but it's not going to equal that. Because these two things are not both in the chart and I work on that. What you got going on right here? All right. You already calculated that top one? I'm talking about you keep the numbers. Yeah, you don't understand. So you figure out. So what now? Yeah, because that one's got two ends, which is the nearly right down here. Yes. So how many spaces is that? Between nearly. How do you do that 1,000 to a maximum? Since he's the biggest for one, how many spaces for the since you know? One. So you put 10. All right. Now, those both of these are cubed. You do what with these? This is the piece we just added. Because those units are cubed, you do what with this? Cube numbers. So, you cube 1 and you cube 10. Okay, so the reason I was asking if you had already cubed that was 10 cubed is a fact. So I wanted to know if you'd already done that in your head or what you've done. I didn't know if you had thought that part in advance or you written down or what. So I just checking. You might have. Where? I do that. All right, that's the number of new units of cubed. Cube that. And cube that. So you're going to say 758 or 75.8, sorry. Times 10 raised to the third equals. What are you asking me? Three, not wrong at all.
Okay.
We're not drawing at all. Where are we at? That number so much. I have arthritis and old age. Last was killing y'all. The only one I've seen who's not drug chart number 3. Two of you.
Pizza.
That's correct. They wrote through chart. All right, can we talk about the questions? Because by my calculations, I'll have about 5 minutes. All right, so 75.8. Centimeters cubed. Centimeters cubed. Millimeters cubed. Who's bigger? How many spaces between centi and milli?
1.
So you got a 10. What can you tell me about both these units? They're both what? So I've got to cube both of the numbers. So when I calculate, I get 75,800 millimeters cubed. Now, number 2 and number 3, I gave you something where they are cubed, non-cubed. A centimeters cubed is the same as a what? Milliliter. So I'm going to draw my chart, 12.8 liters. Liters to milliliters. 1 to 1,000. 12,800 milliliters. Is that right? Okay. Now this one, I wouldn't even draw a chart for it. Milliliters, it's one and the same. 48.2 milliliters. But those of you who did draw a chart, 48.2 milliliters, a lot of y'all did milliliters and you were like, oh, it's the same. Just put ones there. And you get the same answer. Questions? All right, let's talk homework because the bell and I are not getting along tonight or today.